Okay, so this will be the test review pre-calc, the end of chapter 2, covering 2.5 through 2.8. The first thing in here is just doing some simplifying with complex numbers, some operations, adding, subtract, multiply, divide, and just kind of knowing that I squared will be -1 and some things like that. You can basically simplify each of these. And honestly, these can actually be done on your calculator. I have no problem with you doing that. But if you were doing it manually, of course, this one would just be a FOIL problem, 10 minus 5i, and so on. But again, we'll show on a calculator in a second how to keep that going. Also, the division problems, again, you're going to do this on the calculator, just using parentheses. But if you were doing it manually, if you remember, you're going to multiply top and bottom by the conjugate. And you actually get two FOIL problems, the numerator and the denominator, and then kind of simplify everything. And anytime you see a problem like I to some power, it's basically just kind of knowing the pattern. And basically, if I squared equals -1, the idea is to recognize that I to the 4th is really I squared times I squared. You add those exponents there. So it's really -1 times -1 to get a +1. Okay, but again, just to show you real quick, one of them, the first one on the calculator, to do the 5 plus 2i, just to show where the I is and whatnot. Again, just make sure we're using our parentheses. We could do something like 5 plus 2, and then the I is actually right above the decimal point. So you can go second down here to the decimal point. 5 plus 2i, and then multiply that by 2 minus I. Okay, and the calculator will take care of all the simplifying for you, and it'll shoot you out a final answer there of 12 minus I. So for this one, the answer should have been C. If you check the other ones, they all match up there. One other thing you might want to just check in your calculator, if you ever get issues with this, go into your mode and just make sure that that we're dealing with the complex mode here. It helps with certain problems, and honestly, I don't think it really affects any other normal problems you're doing. They all seem to work out fine. So if you ever get a problem, maybe try that out, and maybe that'll help. Just something to think about. Okay, so number 1 should have been C. If we go to number 2, let's see, we want to write the equation in factored form. They're giving us 0. So basically the idea here is that whatever the 0 is, the factor is always going to be x minus that number. Okay, so same thing with the other one, x minus that whole thing. Okay, so there's 2 factors, and then the idea here is, since they gave you a complex factor, this one has the I in there, we know that its conjugate is also going to be a 0. So that would make another factor x minus that 0. Okay, so that's all we're looking for there. We should be able to see that that one's going to take you to, that one's number, the answer is B, and that one would take you to number 8 if you're following the trail. And again, if you wanted to, if you actually had to multiply these out, you'd probably want to distribute those negative signs first and go from there, but this problem's not even really requiring that, just knowing that it's x minus whatever the actual 0 is. So there was a 0, that was a 0, and that was a 0. Okay. Okay, number 3, which of the following are zeros? And they're giving us, they give us one of them. Okay, we got this kind of messy 4th degree term. If 2 minus 5i is a 0, we also know that 2 plus 5i is going to be a 0 automatically. Okay, again, that's that complex root, so it's going to have its conjugate pair with it. Now, I don't know about the other ones yet, so we may have to do a little work and see what happens. So what I would do is sketch a graph of that thing. Okay, let's see if we can get that thing graphed and then and take it from there. Okay, so I went into the y equals, typed in the function, and again, I'm just hoping to get some nice rational zeros, because if we want these exact, we would, my thought process would be, let's look at the graph, see if I can see any nice zeros, and if so, we'll divide them out synthetically to find any other imaginary ones or irrational ones. We can, if we use synthetic division, we can find those exactly as well. But it looks like we're kind of out of luck here. And you might want to play with your window a little bit just to make sure that you're not just missing something. But if I look at the table, it looks like some of those y values, oops, let's see, these x values are a little big, so the y values are really, really high. But if we get closer to our normal window here, Let's see what happens. So still some big y values, aren't they? So as we get closer to our standard window, they're getting a little smaller. um, but then it looks like they start to increase again. So again, you could play with the zoom out and all that and make sure, but it looks like all these y values are all positive. So I'm assuming the graph is just above 0 all the time. So they're probably just going to have some imaginary solutions. So in order to find those, what you want to do is take one of the zeros that you know, okay, and we're going to do synthetic division here, okay, and we're going to use the 0, and then let me get the equation back. The thing that we just graphed, oh, it's right on the board there. The coefficients are going to be 1, -4, 33, -16, and then 116. And what I'm going to do is divide the fourth degree term, the fourth degree polynomial that they gave us by one of the zeros, and see what we get. So I would have to bring down the 1, and then we're going to multiply 1 times the 2 minus 5i. Okay, and here's where it's going to get a little messy. You know, actually this first step, we're just adding those two together. So I'm going to just do the -4 plus 2 minus 5i. So that one should get you -2 minus 5i. And now here's actually where it's getting a little messy, because I need to take that and I need to multiply it by the thing that was in the box, the 0 over there. So that's when you're going to want to use your calculator. Okay, and we are actually going to multiply the -2 minus 5i times 2 minus 5i, and we're going to put that answer up here, and then we'll add the 33 to that, and that answer will go down here. Okay, and I guess I can show you the first step or two on the calculators here. Okay, so I got the multiplications worked out on the calculator. So we first brought down the okay, so let's kind of start. I got off track for a second there, but so here we are. We brought down the, or we added the -4 plus the 2 minus 5i, right? So I'm at this point right here where I have the, that piece going to get multiplied by the thing we were dividing by. So let's go ahead and do that real quick on the calculator, and then I'll just kind of pick it up from there. So on your calculators, you can actually do that by just taking the -2, let's use parentheses, -2 minus 5i, and I'm multiplying that by the thing we were dividing by originally, which was 2 minus 5i. Okay, so times 2 minus 5i. Okay, and that's going to give us -29. So that number is what's going to go up here. Okay, and then what we're doing, just we're adding the 33 to that. So I'm just going to keep the string running in the calculator. Add 33 to that, and that's going to give me a 4 down here. Okay, now that 4 is getting times by the thing we were dividing by, which again was the 2 minus 5i. So I'm just going to hit multiply. I'm going to times that by, in parentheses again, 2 minus 5i. Okay, and that's going to get me 8 minus 20i to go up here. Okay, we're going to add the -16 to that, which is just like subtracting 16, to get -8 minus 20i down here. And we got to multiply that by the 2 minus 5i again. So again, just hit multiply, hit times, use your parentheses, 2 minus 5i. Okay, and that'll get us the -116, which we can see will get us a remainder of 0, which is what we wanted. Okay, so we did one step. Now, what we'd have to do now is take, if you think about what we just did, we divided a fourth degree term. So these are now the coefficients of a third degree term. So we would now have to use the other 0. Okay, again, we knew it was a conjugate, and use the coefficients from the thing we just did, or the thing we just got, and do the synthetic process identically one more time on your calculator carefully multiplying everything out, bring the 1 down, and so on. And what should end up happening is you're going to get yourself a nice quadratic that you can solve using the quadratic formula. And when you finally simplify everything, we should be able to reduce everything down. Let me just check, this was number 3. And we should end up getting C for this one. 2i is going to be one of the roots, and then negative 2i once you do the quadratic formula from the final step. Okay, so that was that one. And again, just really use your calculator to do those multiplications. If you use parentheses, it should work out nicely. And you can kind of make sure everything's working out if you're getting that 0 in the remainder each time. Otherwise, you either made an arithmetic mistake or the thing you were dividing by wasn't really a 0. Okay, okay, so number 4. Which transformations would be done to the parent function, which is 1 over x, based on this function here. So in this case, since that's kind of in a little different form, I see that 1 minus 2x in the numerator, I'm actually going to do the division. I'm going to do a long division, and I'm going to see how many times. I'm going to rewrite the numerator also. We like to write in standard form where the variables kind of are descending the exponents. So negative 2x plus 1 is the exact same thing as 1 minus 2x. And if we do the long division, okay, again, we're just focusing on the first term going into the first term here. I see x would have to get multiplied by negative 2. Okay, and then of course the negative 2 gets multiplied by the x plus 1. And when we subtract, okay, we're going to actually get 1 minus negative 2. So we're going to get 3 up here. That's our remainder. And it's a positive 3. It goes over the x plus 1. Okay, or you could have done this problem synthetically. I've seen people do it synthetically. If you do synthetic, make sure you rearrange the 1 minus 2x. Also, it's going to be negative 2 first, then a 1. But what this tells us now is if we think about that, if you want to just flip the order around, the 3 over x plus 1, and then you have that negative 2 sitting out front is just like a minus 2. And this way it's just a lot easier to compare it because now this form kind of matches up with the regular parent function of 1 over x. And you can see a couple things going on. First off, there's a 3 up there. That's going to be your multiple, so that's going to be your stretch factor. Okay, the plus 1 down here is going to be a horizontal shift to the left by 1. And then we also see that there is a minus on the outside. That's going to be a vertical shift of down 2. Okay, so this one should be A. We had a vertical stretch of 3, we had a shift left, and we had a shift down. Okay, so option A shows all those. And if we didn't do the division, you wouldn't be able to tell what the stretch factor was, right? So the way it was originally written, I can see the shift, and I could do some things with asymptotes, with the degrees and all that stuff, but you're not going to know the whole picture unless you do the division problem. Okay, so that one should be A. Okay, number 5, solving the equation algebraically. So this is one of those rational equations, so we need to um, try and clear those denominators. That's the way we were tackling it. So let me just write this a little bit larger here. If you notice, the denominator under the 25 there is factorable. That's one of those trinomials, and it looks like it would be x minus 3 times x plus 2. Okay, right, because those are the factors of negative 6 that add up to negative 1. So luckily in this case, the denominators on the left, if we look at those individually, are the same too as the factors of the denominator on the right. So if I were to just multiply this entire problem by both of those, meaning multiply by x plus 2 and x minus 3, okay, think of there being a 1 under there, I see that this one's going to get canceled, this one's going to get canceled by the x minus 3, and then obviously they're both going to get canceled by that. So we can just multiply by both of them, and we should get ourselves a much nicer looking equation. So let's actually write it out if we were to multiply. Okay, it would be that times x minus 3 times x, and the first term was all over x plus 2, so we see those will cancel, the x plus 2s will. Okay, the middle term then, x plus 2 times x minus 3 times 5, and that's all over x minus 3. Okay, and a little short on space here. The other side, x plus 2 times x minus 3 times 25, and it was already over x minus 3 and x plus 2. Okay, so now here's the step to make sure we're on track. do all of these things cancel out? And it looks like they do, meaning the denominators. That cancels, x minus 3 over x minus 3 cancels, and then this one happens to have both factors cancel. So the only thing that we have left, okay, we can actually go ahead and multiply these together now. So x squared minus 3x. Okay, in the middle term, again, we're going to multiply the 5 and the x plus 2, so 5x plus 10. And on the right side of the equation is just the 25 now. Okay, so we have ourselves a nice little quadratic equation. We can combine some terms here. This would be x squared. Combining the two x's there would be a plus 2x. And since it's quadratic, we're going to set it equal to 0 and use one of our methods. So you subtract the 25 over. Squared plus 2x, that'd be a minus 15 then, equaling 0. And this one appears to be factorable. If you don't want to use the quadratic formula, I think we can go x plus 5 times x minus 3. And we'll get two potential answers. Okay, x could either be negative 5 or x could be 3. And it looks like that was one of our options, doesn't it? Okay, but we need to make sure in these type of equations that they're not extraneous, that they were not excluded values. So checking out the negative 5, okay, again, if you look at your original denominators, if x were negative 5, none of these denominators will be 0. So x equals negative 5 is good to go. But if x were 3, okay, looking at this denominator up top here, that's going to cause a 0 in the denominator. So this value is actually extraneous. So the only answer is x equals negative 5. Okay, so the answer to this one is B. Okay. Okay, number 6, solve with a sign chart. Okay, so we need to get ourselves the number line. We need to solve this, plot them, do a little interval test. Okay, so what we need, first off, for our critical values, we need anything that's a solution to the equation. Okay, because that would be like a borderline. But also with these, there is an excluded value that we need to mention. This was kind of like the last thing we did in the chapter at the end of 2.8. Any excluded value we know cannot be as part of our solution interval, so we need to mark that on the number line too. Okay, so I think I can see pretty clearly the excluded value would be at x equals 5. Okay, and if we wanted to solve the equation to get the other critical values, let me just rewrite this: x minus 2 times x plus 5. Okay, all over x minus 5 greater than or equal to 0. Okay, if you see something like this, think about if we were to multiply both sides of this. Oops, I should have wrote an equal sign in there. If we were to multiply both sides by x minus 5, okay, just to get rid of this in the denominator, so I'm going to multiply the whole thing by x minus 5. I'm going to do that over here. What actually ends up happening is when that cancels that, and the right side of the equation is still 0. Okay, so you're getting x minus 2 times x plus 5 equaling 0. Okay, and then we can clearly find the two solutions there. X could be 2, x could be negative 5. So those are the solutions to the equation, their critical values. But along with that is the excluded value from the beginning. So we have three things, and all of those need to go on our number line. Okay, so if we plot those, okay, let me just put them in order. Negative 5, then we had a positive 2, and then a positive 5. Okay, and we know that at 2 and at negative 5, the function actually equals 0, but at positive 5, the function was actually undefined. Okay, and what we would do then is go to the graph or to the table. Okay, so why don't we punch that in real quick, and we will see, is the graph positive or negative in each of these intervals here. Okay, so let's do that real quick. Okay, so I went ahead and entered the original problem, okay, into the calculator. So basically just, again, the original expression, okay, I made sure to use parentheses, the whole numerator is in parentheses divided by the x minus 5. I've seen some people missing the division bar in there too, so make sure we don't miss that. And now what we need to do is determine is the graph, okay, I'm actually going to show you guys in the table. Um, in each of these intervals, are we getting positives or negative values? Okay, so what we can do, if you want to look at the graph, you can take a look and see it, but sometimes it's a little difficult to see with these rational functions where they are. But that's kind of what it looks like. So I can see, you know, majority of this thing. My issue is I'm not seeing in that far right interval out here when the x values are bigger than 5. I'm not really seeing anything on my graph. So sometimes the table's a little bit helpful. So if we pull that table up, okay, and we look, and let's just go, so my first interval on the far left has to be any number less than -5, right? So if we go out here, I can see right at -5 I get 0. That was one of the solutions we got. And then all of the values are negative y values. I'm looking at these values. So that's telling me this entire interval is having negative numbers. Okay, but then as soon as if I look in my second interval, so I'm looking, if I look in between -5 and +2, okay, so if we go to our table and just kind of scroll a little bit, from -5, again, that's when the y value was 0. Look at all the y values when x is in between -5 and 2. All those y values are positive. Okay, and when I get to 2, again, it equals 0, but we knew that when we solved it. But all the y values in this interval were positive numbers. Okay, now in between 2 and 5, okay, again, those y values, these y values are negative again. Okay, and as we scroll down, I see there's my undefined value that we set up from the excluded value. And any number past 5, again, these didn't show up on the graph. See, these are big numbers, but the y values are all positive numbers. I can tell just by looking at the table. So those are going to be all positive. So what we can do is now look back to our original problem and ask ourselves, you know, which ones are we looking for? And in the original equation, or the original inequality, was asking for where are the numbers greater than or equal to 0. Okay, so using our sign chart now, we can write a conclusion. They're greater than or equal to 0 from here to here, okay, and including those endpoints, because they equal 0 at -5 and at 2. But then picking it up from 5 and up, okay, but remember, right at 5, the graph's undefined. So the way we're going to do that is with our interval notation, we're going to say something like any x value from -5 to 2 works, union, I have to use a parenthesis here, okay, because again, I can't include 5 because the graph is not greater than or equal to 0 when x is 5, it's undefined. Okay, but as soon as I get to 5 and get just past 5, then we're good to go. Okay, so that one should be, which number was this, 6? That one should be D, from -5 to 2, or from 5 to infinity. Yep, there's our solution there. And you got to watch the parenthesis or bracket deal. It does make a big difference. Okay, next problem, number 7. This one should be a little quicker. They kind of handed you a graph. They want, you know, when is the function less than or equal to 0. So again, as I'm graphing this thing, it's increasing, but it's still less than or equal to 0. It looks like we might hit 0 there, but we're still less than or equal to 0. We're still less than or equal to 0. Still less than or equal to 0. Till I get here. But once I get past there, then we're not good anymore. Then we're positive. So it looks like for all x values, okay, as long as we are, think about, here's our number line. This is like the stopping point, and that, if you could zoom in on the graph a little bit, I believe that's at 5. But all x values less than that work. Okay, because I'm assuming this thing just continues down because we don't know any different. But as soon as we get past 5, we don't meet that condition anymore. So any x value from -infinity to 5, including 5. Okay, now if this question had just said when is f of x less than 0, then we would have to watch for that one point out here when the graph kind of came up and hit. Okay, because technically right here the graph is not just less than 0. So if that were the case, we would have to go with option, it'd be more like option B. Okay, but again, since this equal sign was in the original problem, that point is okay. So that's why it's all x values from negative infinity all the way until you got to that point at 5. Okay, and our last one, let's find all the zeros exactly. So again, it doesn't look like they gave you any of them, so why don't we start out with a graph and see if we can get anything to help us. Okay, so I went into my y equals, typed the equation in. Let's see if the graph gives us anything to work with here, and it looks like, there it goes. Okay, so it looks like we have one nice one. Okay, again, if we need these exact, they need to be rational numbers, otherwise we got to find them with a quadratic formula. So this one, it appears like positive 2 is a 0, so I can check in my table since it's a whole number. And I can verify there that positive 2 is going to give me a 0. Okay, so you just give me some sort of explanation from the graph, or you give me a quick sketch. I know that x equals 2 is one of the zeros. Okay, now you could play with the window and see if you think there's going to be another one or not. But I don't think this one has one. So we're going to have to do some synthetic division again. So let's take the 0 that was given to us. And let's take that, again, the factor would be x minus 2. So we're going to divide by regular 2 synthetically. So my coefficients, 1x to the third, 4x squared. Okay, a lot of people might not have recognized, but there's a jump there. Okay, there's 0x to the first. Okay, so make sure we account for that. Again, I can't go from the third power to a second power to no power. So that 0 needs to go in there. We'll do our synthetic, bring down the 1. I'm just getting ahead of myself. And then multiply that by 2. We add those. 6 times 2. Add the 0. Multiply that by 2. And again, we're getting a 0 here. That kind of confirms that it is a 0. So positive 2 works. And of course, this gives us a quadratic. Here are my coefficients. We could just go ahead and solve that using the quadratic formula. Okay, and we would do negative b over plus or minus square root of b squared, which is 36, right? 6 squared, minus 4ac, all over 2a. Okay, and then we'll just go ahead and do some simplifying, okay, because we need these exact. So I'm looking for the value of the discriminant here. That'd be the first thing I would calculate. And let's see, that would be what? 36 minus a 48, so it sounds like a negative 12. Okay, and this is kind of verifying we're going to get imaginary zeros, that discriminant's negative. Okay, so negative 6. If you simplify the negative root 12, right, remember it's root 4 times root 3, and then there's that negative 1 factor in there, so looks like 2I root 3. Okay, and then of course the coefficients are both divisible by 2, so let's go ahead and do that. Negative 3 plus or minus I. We don't divide the root 3, we're just dividing the coefficients. Okay, so that got divided by 2 and that got divided by 2. So that would be your other zeros. To go along with the graph showed positive 2, and we can see our answer there is C. Okay, so give those some practice. Be careful with synthetically, using the actual 0 in the box. Be careful with parentheses on a lot of this stuff. And use your calculator. If you're ever stuck on an equation, see if there's a nice one you can get. If not, if they're all irrational or all imaginary, we really can't do anything with it. So you should always be able to get at least one, from the graph, or from, they'll just give you one of the imaginary ones to find all zeros. All right.